Now let's say the MOSFET, as you see here. So we have here two images. These are two symbols of MOSFET. Okay, so the symbol of MOSFET is slightly like the symbol of the transistor, but there is some differences. As you see here for the MOSFET, so this is the symbol of MOSFET as you see, okay? And its terminal is three terminals, exactly like the transistor, okay? So we have the first terminal, the second, and here we have the third. But the name of terminals is different. Here we have the gates, as you see, gate, and here we have drain. In place of collector, we have drain, and in place or instead of emitter, we have source. Okay? So gate, drain, and source. So this is the NPN MOSFET transistor, and this is the P MOSFET transistor. So for those, there is a difference between the arrows for the MOSFET and the transistor. Okay, so for the in MOSFET transistor, the arrow is goes from source to gate. Okay, from source to gate, but in the transistor, the opposite. Okay, and for P MOSFET transistor, the arrow goes from gate to source, as you see, from gate to source. But in the PNP transistor, the opposite. Okay, so this is the MOSFET as you see here. So the working principle of the MOSFET is the same as the transistor. Okay, so we have gate here. When we get some voltages or current here, for example 3 volt or 1.5 volt, for example, the current will flow between drain and source. Okay, so that's why we use the MOSFET in the switching mode. Okay, because the MOSFET can be open and closed, can be on off, on off, on off, in accordance with the voltage or the signal, the enabled signals that get or that arrives in the gate over here. Okay, so this is the symbols of transistor, and this is the symbols of MOSFET. Now let's see another symbol, a special symbol, as you see over here. So this is a Darlington Pair Transistor. Okay, the Darlington Pair Transistor, this symbol or this kind of transistor is composed of two transistors. As you see, this is the first one and this is the second one. Okay, so let's draw it here. As you see, so we have here collector and we have here base. Okay, as you see, and we have here emitter. Okay, so the emitter of this transistor will go to the base of another transistor. Okay, as you see, we have here collector and we have here emitter, and this is the base. So the emitter of the first transistor go to the base of the second transistor. So this is a Darlington Pair transistor. As you see here, we have a base, the first transistor, as you see, and we have collector. So the collector of the both transistors is connected together, as you see here, and the emitter of this, as you see, the emitter of this transistor goes to base of this, as you see, and we have the emitter of the second transistor. So when we have here, for example, when we get a voltage here, for example, enabled voltage, this transistor will be activated. So the current flow will happen over here. Then the second transistor will be activated and the current or the flow current will happen over here. So this is a Darlington Pair transistor working principle. Okay, so this kind of symbol or of technology is used in many motherboards. Okay, so this is all about transistors, MOSFETs, and a special symbol or special montage that called Darlington Pair Transistor.